Okay, we have f plus g of x. Well, f plus g of x equals f of x plus g of x. And that equals x cubed minus 3x plus 4x squared minus 7x plus 2. And I didn't leave myself a lot of room here. I'll remember what I had down here. Room. And that equals, well, we can remove the parentheses, x cubed minus 3x plus 4x squared minus 7x plus 2. Now we can rearrange these terms in order of exponents. So we rearrange first one, x cubed first. The next power of x is the 4x squared. We've only got a 4x squared, so we got that. Then we got minus 3x minus 7x plus 2. Now, does anything simplify? We can't add x cubes and x squareds. We can add x's and x's, right? So negative 3x and negative 7x would be negative 10x. We got a plus 2 there, that's all we have. So we got x cubed plus 4x squared minus 10x plus 2. Now, there were problems in the homework that most people that did the homework got right. Okay? But you didn't get it right when you did it here. There's one person that screwed it up but did it right here too. Okay? Somebody tried to add an x cubed and an x squared, but they no longer believe that's valid. It isn't. Why can't you add x cubed plus x squared? Well, first of all, it's easy to confuse that with x2 cubed times x squared, which equals x times x multiplied by x times x. And that is x to the 5th. X cubed plus x squared is not x times x multiplied by x times x. It's x times x plus x times x. That's not a multiplication. So you're not getting x to the 5th out of that. Okay? No place where you got 5x's multiplied to do it. Okay? So you might want to make a note of that. Of course, it's right there on the video. If you just kind of click through the videos, you can see what I'm doing and look at stuff that you need to refresh yourself on a little bit. Okay, now I didn't leave myself room to do f minus g of x, so I'm going to do it down here. Actually, it was g minus f, wasn't it? That just means g of x minus f of x. And that's going to be 4x squared minus 7x plus 2 minus the quantity x cubed minus 3x. And when we work that out, we're going to get 4x cubed minus 7x plus 2. Now the negative distributes through this expression. So we're going to get negative x cubed plus 3x. It's real easy to make a sign error there, so you really want to be careful when you have a negative and you have to distribute it. Very easy, especially if you're in a hurry. And you don't have that many problems. People seem to be spending an average of about an hour on homework assignments. Some people up to twice that, some people getting it done in half that. Okay? But it's worth taking the time to do it carefully and write everything out. And let me also mention that when you're asked to, actually not doing that much of it in here. Some cases you're asked to submit copies of your work, means copies of all your work in a single file. Okay. I got one, strangely, that had 4 links in a note in a PDF. PDF just had 4 links. You click on the link, and the page comes up. Okay. And I really want to see it on the page. I don't have to be manipulating a bunch of links because I got a lot of these to go through. Okay. Now, if you do that, I'll give you a little note, little suggestion. Do it 3 times in a row, and oh man, I don't know what's going to happen. But yeah, read my notes. But the one that I saw that was in that format had the same thing in all 4 links. Might have been intended as links to 4 different pages, but I don't remember whose that was. So I don't know if it was even in here. Probably wasn't. Okay. So some people are just sending me a single JPEG of one of their pages. And I'm not, as of today, I'm no longer giving full credit for that. I give you, it's 5 points. I'll give you 1 point for sending something. I'll get something there. And then the other 4 points, you got 1/4 of the pages or 1/4 of the problems. That's another point. If you got half of them, that'll be 2 more points. All that stuff, okay? So make sure I'm getting all the pages. All right, well, back to the problem. We got this, and then that simplifies easily. Except I copied this x squared as an x cubed. Anybody notice that I did that? If you notice and you didn't want to say anything, remember, if I've got squares and cubes floating around, I'm already looking ahead while I'm writing down one thing, and sometimes whatever my eye's on is what gets written. Okay. So when I say take your time and be careful, I don't want to take too much time to do these, so I'm not as careful as I could be. So I will make mistakes. I usually catch them because at the end I'm going to check. All right. Okay. So anyhow, we have this. Okay. So we put this in the order of exponents. And we see the 7x and the 3x goes together. Okay. Just like they did here, except they have opposite signs. You got negative 7x and plus 3x. And of course, 7x minus 3x is 4x. And there's your g minus f of x. So those are actually very easy. You just got to keep your wits about you and make sure you add like terms. Now, this is a little more difficult, but of course, we've seen this, and I've done some examples with composite functions with the toolkit functions. Okay. So this shouldn't be anything new to you. F of g of x, that's a bad looking g. I don't know what you might interpret that as, but there's a little more like a g. Well, as I've said, as I will continue to say, here's your rule for f of x. You have f of g of x, right? You replace x by g of x. So all these x's become g of x's, and you get f of g of x equals. Okay, if we replace every x here with a g of x, we get f of g of x equals g of x cubed minus 3 g of x. It's very straightforward. We're just changing all of our x's to whatever's inside here. It's how you write down the rule for a composite function if you have the formulas for the two functions. At least that's your first step. Then your second step is whatever g of x is, you're going to write for g of x. So that's going to equal 4x squared minus 7x plus 2 cubed minus 3 times 4x squared minus 7x plus 2. Now that equals, I'm not going to cube this because it would take too long. I don't have that much board space. Okay. Now I don't want to cube it in my head because I'm sure I'd make a mistake somewhere. So I'm going to do this, and we'll worry about how you would cube something like this later. Okay. You might know it's just distributive law, but gets a little bit more involved. So don't worry too much about that at this point. But then we have to take the minus 3 times all this. So what we get out of this is minus 3 times 4x squared, which is, excuse me, negative 12x squared. Minus 3 times minus 7 is 21 plus 21. And that's got an x on it. And negative 3 times 2 is minus 6. I'll just say equals, et cetera. The et cetera is how do you cube this? And then how do you simplify the whole mess? Okay. Now, g of f of x, something we can actually do and we can actually simplify. G of f of x, we're going to get g of f of x if we replace x by f of x. Of course, to replace this x by f of x, you got to replace the rest of the x's by f of x. We'll replace all our x's by f of x, and we get 4 f of x squared minus 7 f of x plus 2. That's all there is to using this notation with a couple of formulas. I mean, at least that's the first time. The rest of it's just algebra. Well, I say just algebra because the algebra can be a stumbling block. Okay. And then we go ahead and replace the expression f of x with the formula for f of x. We get 4 times x cubed minus 3x minus 7 times x cubed minus 3x plus 2. And of course, this one is squared. Okay. Now, there are special products, and if your algebra is fairly fresh, you know, it's pretty easy to square a binomial. So I'm going to go ahead and square that one without going through the details. You're going to have an x to the 6th. You're going to have minus 6x to the 4th plus 9x squared. You don't square this and square this and leave it at that. That's not how it works. You have to multiply this by itself. And you know, I am going to just write that out so you can see it. You got x cubed minus 3x multiplied by x cubed minus 3x. That equals x cubed times x cubed minus 3x minus 3x times x cubed minus 3x. This is a little small. I'm going to do it kind of quickly. If you can't see it where you are, you can take a look, you know, 12 minutes into the video or whatever it is. And then you multiply this out, you get x to the 6th. And you multiply this, you get minus 3x to the 4th. And here you get minus 3x to the 4th. And here you get plus 9x squared. And that equals x to the 6th minus 6x to the 4th. That's 9x squared. So that is the justification for this expression. And I don't intend that you learn how to do it by watching just what I did, but you can see at least that you ain't getting x to the 6th and 9x squared and nothing else. And the reason is the x cubed here multiplies the negative 3x here, right? And the negative 3x multiplies the x cubed here. So you get a couple of negative 3x cubes there. Okay, or 3x squared. Which gives you 3x to the fourth. It's x cubed times 3x is 3x to the fourth. You get a couple of those, and that's where this comes from. So it's worth just reminding yourself that when you have a square of a sum of two quantities, you don't just square the two quantities. It's a very common error. So just kind of make a note and try to avoid doing that. Okay, we'll talk more about it when we actually get into it. Okay, then we get this and this. Have room. Well, I'm going to make the table and the graph on a different board anyhow, so I'm just going to erase. Give myself room. We get 4 times all this. That's going to be 4x to the 6. 4 times negative 6 is negative 24, and we've got an x to the fourth there. 4 times 9 is 36. We have an x squared, and it's minus 7x cubed plus 21x plus 2. Sign down here. Okay, now we do the highest power to the lowest. We have x to the 6th, so we have 4x to the 6th. Then we have an x to the 4th, a negative 24 x to the 4th. And we have a 36x squared. I wasn't looking when I wrote that. I kind of ran it together. Okay, 36x squared. Uh-oh, try to do them in order. I don't want to write out my x squared term before I write out my x cubed term. I have the negative 7x cubed, and then the 36x squared, and the 21x plus 2. So I didn't have to add any powers. Okay, didn't have to add any terms. I just had to put them in order from highest power to lowest. Now, ordinarily, when you do that, the majority of the time, you're going to have to do at least some addition like we did down here or here, because there would be some if we did this. Actually, there wouldn't. Okay, anyhow, it doesn't matter. Okay, do we understand the notation? How to do an f of g of x and a g of f of x? Okay. Again, I'm questioning in my mind how people manage to get these right, but weren't able to get them in class. Some of you did get them. Some people got them right on homework, didn't get them right in class. So make sure that when you do your homework, you're doing it in such a way that you remember. And, you know, maybe you just didn't get any sleep last night and you're just worthless today. Okay. That happens to me all the time, most days. All right. Now let's go to the last problem. You know, I'm wondering what's going on here. Why the board isn't getting cleaner. It'll take just a second. Test it because I thought that I'd gotten all that stuff off. I used to do this with the squeegee using water. Turns out to be faster to use them. And then I'd use the spray. Turns out to be faster just to use the spray. But if I'm getting smudged boards, might have to go back to the water. It isn't that bad, just a little messy. The board should be coming cleaner than that. Okay. So we're gonna graph. We got y equals x squared. We want to evaluate it. For x equals 0, 1/2, 1, and 2. Now, people who in my class went ahead and constructed the grid and did that. In my pre-calculus class. It's okay, we're not doing that in here. Okay, because not all classes are doing that. So I don't want to take time and do something that some of you are not familiar with. Okay, so anyhow, we got y equals x squared. We say that the way to make a graph, the way I like to make a graph, is to put the biggest value of y here on a horizontal line and the biggest value of x here on a vertical line. And then I'd like to cut the intervals in half. So halfway between 0 and 2 is x equals 1. I've got a line there and I get a grid. And then I can cut this interval in half. That gives me the line where x equals 1/2. And if I want to cut this interval in half and get 3/2, not 3/4. Then for y equals 4, cut that in half, get y equals 2. Cut that in half, get y equals 1. But I need a fourth. Equals 1/4. So class, I gave you an algorithm for doing this, doing it in a 4x4 rectangle and so forth. So you have to be able to do that in my class. But for some other functions, you'd make a table. And I still advocate using numbers that you can cut in half. But you can make your own decision on that. We get these points: 0, 0, 1/2, 1/4, 1, 1, and 2, 4. The graph starts out flat, then it starts curving up. Goes up like this. Not a perfect graph, but it's not too bad. We get the shape. Okay. Now, what we want to talk about, because your upcoming assignment is on inverse functions. And some of you, how many in your next class? So, giving you a little bit of an introduction. As I say, I like to introduce this before we see it in class, so that when you do see it in class, you understand it better. Inverse function. And I'm going to actually put a little more notation in here. Y equals f of x equals x squared. So now we've given the function a name. We're still doing y equals x squared, but we're giving a name to the value and calling it f of x. The inverse function. First of all, we give it a name. It's like f with a superscript of -1. That doesn't mean a -1 power, though. That's just a notation that we use for inverse function. It's not the -1 power of f. F isn't a number. You can't take the -1 power of something that isn't a number unless you define it somehow. It's something we do, at least in a pre-calculus calculus sequence. Okay, so there's our inverse function. Now we want a table. And I'm going to just make sure we see the distinction. Here, y equals f of x, which is x squared. Here, y equals f inverse of x. Okay, well, I want you to make the table. I've started it for you. Of course, you need 4 rows. And all you do is you take the numbers in the second column, numbers I'm pointing to here, the numbers 0, 1, 4, 1, and 4, and you put them in the first column. And then what do you think you're going to do with the numbers in the first column, 0, 1, half, 1, 2? You're going to put them in the second column, right? So see if you can do that, and then see if you can make a graph of y versus x for the inverse function. We'll see how far you get, and then we'll talk about it. Okay. So this is really a very simple process once you've seen it once. Okay. We're just switching x and y. Okay. So where x was numbers from 0 to 2, these numbers are going to go in the x column. So we're going to put 0, 1, 4th, 1, 4. We've switched x and y. The y values here become the x values here. Okay. And some people did this table correctly, but labeled this y and labeled this x. We don't switch the labels. We switch the values of x and y. Okay. And then, of course, the numbers in this column are the 0, 1, half, 1, and 2. So I'm going to make a graph of this function. Now, a lot of you made a window, made it right. Okay. We need x equals 0, and we need x equals 4. Okay, so if you got that, that's pretty good. And the rest of it won't be difficult. And then we have y equals 2 up here, and y equals 0 down here. Now, if you want to divide things up, which is pretty easy to do for the x values, okay, you could have x equals 2, x equals 3, x equals 1. We've got y equals 2, y equals 0, so we're going to have y equals 1, and we're going to have y equals 1 half. Now we've got y equals 0, 1 half, 1, and 2. We don't need to do any more on this graph. If you're in my class, you're probably used to subdividing this down to the quarter, maybe even down once more. Well, that's what you need to do to follow the algorithm I've given you for the x squared function. But if you're not in my class, it doesn't hurt to do it, but it's not necessary. Okay, but you're going to see what happens. Okay, now do we have all our x values on the table? Our x values are 0. Well, there's 0. And we got 1 and 4, right? There's 1 and 4, right? But we don't have 1/4. So what we're going to have to do is we're going to have to divide up the interval from 0 to 1. Here's x equals 1. And divide that in half. And this is x equals 1/4. Here. Okay. So doesn't that just look like this table kind of turned on its side? This one goes from y equals 0 to 4 with values 1 half, 1, 2, and 4. This one, the x values go from 0 to 4. Well, why is that? Just because the x values are exactly what the y values were over here, isn't it? Okay. And the y values, we got 1/2, 1, and 2. 1/2, 1, and 2, and 0. We don't need any more than that. So now we graph the points. 0, 0. Well, that's no surprise. 0, 0 is the same whether you switch the numbers or not. Then we have 1/4, 1/2. X is 1/4. That's on this line, the x equals 1/4 line. On y is on the y equals 1/2 line, so it's here. So the graph is very steep from here to here. Whereas this graph is very flat from here to here. Okay, between the first 2 points. Then we do 1, 1. Oh, here's x equals 1, y equals 1. That would be here. And then x equals 4 and y equals 2. We go all the way up to x equals 4 and up to y equals 2. And look at what we've got. Okay, we've got this graph that's very steep here and isn't very steep at all by the time we get out here. Now it keeps going up. If you extend this graph out to x equals 10 million, it's going to still keep going up, but it's going to go up very, very slowly. And you don't need to know that just yet. But I'm going to do something with the formula, hopefully convince you that. Okay? So the rule is, this is a little oversimplified. Read your text, do everything they say, learn what they tell you. Ask AI. Remember, you don't ask AI to do this homework problem or that homework problem. Ask AI to explain something to you. Okay? The inverse function. So ask AI. You know, a good prompt would be, explain inverse functions to me. Okay? I know some algebra. I'm in a pre-calculus class, and I'm having trouble understanding inverse functions, or I'd like an explanation of inverse functions, even if you're not having trouble. See what AI tells you. That's a good way to use AI. AI can make a great tutor. It's got its shortcomings, but it can be a valuable aid to learn. Okay? So the inverse, if it's used right. So for an inverse function, we switch x and y. And that's what we just did. Does that make sense? Okay. Now, we're going to do just a little algebra. We're going to take the original function, and I'm just going to write the formula for it without the f of x. We know that's the f of x function because we just defined it that way, okay? So say the original function f of x, we might as well mention its name. It likes to hear its name, okay? Now the inverse function, f inverse of x, that's how this is read. F is a superscript -1, parentheses x is read f inverse of x. It's x equals y squared. Okay? We want to solve this for y. Well, we write down x equals y squared. We want to solve for y, so it's kind of looks a little better to us if we got the y on the left. So it's y squared equals x. Same thing as x equals y squared. reverse the sides of an equation without changing the solutions. Okay, how do you solve the equation y squared equals x? Well, the solution to that equation is, and always has been, y equals plus or minus the square root of x. Make sense? If you understand anything about what a square root is, it should make sense. But people, I hypothesize it's because the SQR and SQRT buttons in your calculator look the same and people don't know the difference. They just punch buttons. And I see a lot of it. I talk about square root and people write SQR. Okay. And they do a square. So make sure you don't get into that. I think 30% of the people come into pre-calculus, maybe 50, don't know that distinction, don't really understand what a square root is. Okay. So make sure you do. You'll have the good sense to be in the support groups. So I assume that most of you know the difference. If you don't, make sure you get it. Okay. Anyhow, y equals plus or minus the square root of x. For example, if you have y squared equals 25, okay, what's the square root of 25? It's 5. Okay, if you square 5, you get 25. So it's just checked it. It's a solution. 5 is a solution to y squared equals 25. Okay, how about negative 5? Is negative 5 a solution? What do you get if you square negative 5? You get 25. You have two solutions. And that is, of course, because if you had this graph, you know, if you made a bigger graph, you might have y equals 25 up here, and you would have two x values that go with that. X equals 5, x equals negative 5. Because the x squared graph is a complete parabola. Okay? Why did I only tell you to use the numbers from 0 to 4? Why didn't I tell you to use negative numbers? Well, if you'd used negative numbers, first place, this parabola would have had the left half. Some of you drew it with the left half, and I'll show you what you do about that. So it's like, okay, yeah, if you complete this thing, you know, this is part of the parabola, y equals x squared, right? So the y equals x squared graph includes this part and this part. But I only asked you to graph this part. And if you graph both parts, that's okay, especially in my class, that's kind of automatic, and I kind of want it to be automatic. What we're doing is, so if we use these numbers as well and reverse the table, we would have had the parabola kind of laid on its side. Okay. And now there'd be two y values for every x value. For x equals 2, we'd have y equals 2. Or so, I'm sorry, for x equals 1, we'd have y equals 1. And we'd also have y equals negative 1. You can't have that for a function. So in order to make this a function, we restrict the domain of the x squared function. And the domain only includes values of x that are greater than or equal to 0. Now we could have chosen this branch, but we don't want to worry about the negatives, okay? So point is, if we restrict the domain to positive values of x. And since we're switching x and y, we restrict the range of values here to positive values. The domain of this one becomes the range of this one. Now, when you did the assignment section 1.1 or the assignment on, the toolkit functions, the square root function was one of them. And it showed you the graph of the square root function. If you remember what the graphs look like, it looks like this. Okay, doesn't have this, because if it did, it wouldn't be a function, would it? And I think pretty much everybody did the homework, was able to identify what was a function and what wasn't. So you know that if I include this here and include the negative x values in the table, when I reverse things, reverse columns, I'm going to get this. I don't want to get this. I just want to get this. That's what the square root is. Okay. It doesn't change the fact that the solution to y squared equals x is plus or minus the square root of x. And that's important, as you're going to see pretty promptly. Okay. Well, that's an inverse function. Now, the assignment you saw didn't include, on the toolkit function, didn't include the basic exponential function, y equals 2 to the x. I don't think. Okay. That's because usually we don't study the exponential function until after we studied polynomials. But I include it because, first place, it's easiest one to construct a graph for. In the second place, because its applications are maybe the most relevant. As we saw in pre-calculus class last time, I'll just mention it here. You're not responsible for it if you're not in my class, of course. That exponential function tells you what happens to an investment at constant interest. Fish into an empty pond with plenty of. So I just mentioned that. If you're not in my class, you'll see that another month or so. Here in my class, you've already seen it. And I mentioned that the graph of the exponential function looks a whole lot like this, but the curvature is somewhat different. And it doesn't go through the origin. If you do the graph of the inverse of the exponential function, it's going to look a lot like this, but not quite. It's going to go through exactly the same points. Some of them. Okay, anyhow, you get the idea. Basic idea that you need to keep in front of you is that you're switching x and y. And here are the mechanics of how you do it with this function. How the graph changes and how you get the equation for the inverse function. And also, we can now say that this inverse function equals the square root of x. What's the square root of 4? What's the square root of 1? What's the square root of 1/4? 1/2 times 1/2 is 1/4. What's the square root of 0? It's 0. You didn't have to know anything about square roots in order to take the squaring function, reverse the columns, and draw the graph. And now you have the graph of the toolkit squaring function, square root function. So this is The inverse of the exponential function is called the log function. But we haven't even talked about that in my class. We've talked about the graph of the exponential function. And we'll talk about it in here closer to the time when everybody needs to see it. Okay, any questions on any of this so far? Because what comes next with inverse functions is a little bit of algebra. So you're going to have to try to pick up on the algebra. Okay, let's take this and let this be f of x. So say y equals f of x equals square root of x plus 4. What's y equals f inverse of x? What's the formula for the inverse function? Now we could graph this too. We have the graphing techniques. We haven't really talked about transformations. Talked about transformations in some of the other classes by now, haven't you? Y'all talked about transformations? I mean, I've talked about them in my class leading up to it because I want people to actually understand it. So we've been talking about it for a long time. We just haven't done it formally. It'll be coming up next week in my class. So we're replacing x by x plus 4. I know that the graph of this thing, just for completeness, here's your graph of y equals square root of x. If you replace x by x plus 4, you just move this thing over 4 units. The graph of y equals the square root of x plus 4. There's to it for this particular graph. So you could sketch that graph and sketch the inverse and estimate values and all that stuff, but we're not going to do that. We're just going to go to the formula. Okay. But putting it in context, that's important. That's one of the things people have the most trouble with in the course. Remember, the inverse function, you switch x and y. And you do a problem where you have to find the inverse. Remind yourself that we're switching x and y. Keep writing it down so you won't forget it, because it's the key to being able to do it. You might forget how to do all the steps. You might have a function that's unfamiliar and it just blows your mind, and you forget what in the world you're doing. If you can write down switch x and y, that gives you a toehold to grasp onto that problem with. And then if your algebra is okay, you can proceed. But if you don't remember to switch x and y, you're dead in the water. So keep writing this out on your homework. Switch x and y, switch x and y. Whatever number of problems you have in your homework, write it down at least that many times. And then maybe at the end of the problem, I just switched x and y. Whatever. Okay, so we switch x and y. Okay, where do we switch x and y? Well, we have y equals the square root of x plus 4 becomes x equals the square root of y plus 4. Make sense? That's what happens when you switch x and y. If you got a table, of course, you can switch values, make a graph. That's fine. But to find the formula, you have to have the formula for f of x, and then you can switch x. Another thing that you probably want to write down is, what do you do once you switch x and y? You solve for y. You ought to write that down every problem. Okay? If you do, you're not likely to forget it soon. And if you do forget it, when you review for test, it'll remind you because it'll be there. Okay? Okay, x equals square root of y plus 4. Solve for y. Well, first thing I'll do, just to make it look more appealing, is I'll put the y expression on the left. It's not necessary, but it looks better and it feels better if you do that. Whether you put it on the left or leave it on the right, how are you going? Now, of course, you're supposed to know that when you come into this course. Time well enough that it comes back to you. And if it doesn't, you're going to have to do a little work to remediate that. Okay? But there it is. Square root of y plus 4, quantity squared equals x squared. And now what do we get if we square the square root of y plus 4? We get y plus 4. Okay. Now we can solve for y. We can add negative 4 equals negative 4 to this equation, and we get y equals x squared minus 4. So now f inverse of x equals x squared plus 4. Okay. If you graph f squared plus 4, it's the same as the graph of x squared, but you got to raise it up 4 units. So in this graph, your graph of x squared would be raised up 4 units. But there's x squared plus 4. If you take this part of the graph here and switch x and y, you get this. And if you can see that, and that's kind of hard to see, so don't worry if you can't. If you can convince yourself to see that, if you can got yourself a good graph of this function and this function using transformations, it becomes very clear how this is the inverse function for that. I don't have the scale quite right here, so it's not quite as obvious in what I did. Just saying, if you understand transformations, you can construct both of these graphs very quickly and easily and see that the right-hand branch of this thing, the one to the right of the vertex, you switch the x's and y's, you get what you get if you take the square root function and move it 4 units to the left. You probably don't understand that right now. I'm just kind of trying to loosen the soil in your brain a little bit so this can grow. All right. Another example, let's say these are simple examples, and some of the examples you have and some of the examples you see in the text are a little more complex. But right now, I'm just trying to give you the idea. Y equals 5x minus 2, and that's f of x. So let's write y equals f of x equals 5x minus 2. We've got about 3 or 4 minutes left. See how far you can get in finding the inverse functions, and then I'll do it in about 30 seconds. And if you don't understand it, you can look at the very end of the video. Okay, well, you got it. I think about half the class got it. Half is still kind of puzzling, but here we do, switch. X and Y, and you get X equals 5Y minus 2. And then you solve for Y. You want to write this out? You want to do that? And then you write solve for Y to remind yourself that's what you do. You get 5Y minus 2 equals X. 5Y equals X plus 2. There's some dots there. There's something you ought to fill in. And you ought to divide both sides by 5, but you're going to get 5Y equals X plus 2. You're going to get Y equals X plus 2 over 5. And that's it. There's your inverse function. Then maybe you write down F inverse of X equals X plus 2 over 5. Then if you do the composite of this with this, you get X. But I'll let open math tell you about that. Make sure you understand how to do composites. And as soon as you got that, you're ready to go. Make sure that's a little clearer.